Okay, 4.7. We have in the past, we've done transformations with lines. Okay, we use that information on the sheet with lines. We've done it with parabolas. Now we're going to do it with all polynomials. Okay, so third degree, fourth degree, fifth degree, things like that. Okay, so if you have your sheets, make sure you're on the back side with Pascal's triangle. We're at the bottom. Okay, with all our different transformations. So let's just jump right into example 1 because the core concept they give us there we already have on our papers. So looking at example 1, they want us to describe the transformation from f of x equals x cubed, and we are moving that into g of x equals x minus 3 cubed plus, minus 1. Okay, so the question is, first describe the transformation. Is it a translation, reflection? Is it a horizontal stretch, shrink, vertical stretch, or shrink? And then they want us to graph both of these. Okay, so looking at our sheets, which type of transformation changes the inside of a parenthesis like that with addition or subtraction? I heard translation and stretch or shrink, but they're both horizontal. Which one is it? It's a translation. Okay, so on your sheet, you should have one that looks like f of x minus h, right? Yes. Okay. So what is h in this case? 3. It's positive 3. So is that a translation left or right? Right. Right. How far? 3 units. Okay. Why is that confusing sometimes?
Because there's a minus 1.
Right, because that says minus, right? So naturally you want to say left or down. Okay? But on your sheet, remember it's x minus h. So it's always a minus sign. So for h must have been a positive 3. Okay? What does this negative 1 on the outside do for us? Okay, it's a vertical translation. Where? Down 1 unit. Because this on ours says f of x plus k, correct? Since it's plus, whatever that sign is correct, I guess, right? If it's negative, it's going down. If it's positive, it's going up. Okay? Does that make a little more sense already than what it did 2.5 months ago when we started this? Okay. All right, so the next part, now that we've described our transformation, we know it went right 3 units and down 1. They want us to graph both of these. How do you graph something like that? What do you mean, multiply?
Can you do your...
We're just going to plug in some points. Yeah, we're going to make our XY chart. Okay, what points did we always pick here?
Negative 2, negative 1, 0.
Good. Negative 2, negative 1, 0, 1, 2. Those are just the easy ones. Okay. Before break, we talked about sometimes you might have to go back and pick more numbers, right? Mm-hmm. Okay. So I take negative 2, I plug it in for x, I get close. Negative 8. Remember, negative 2 times negative 2 is positive 4 times negative 2 is negative 8. Negative 1 cubed is negative 1. 0 cubed, 1 cubed, 2 cubed, 8. Okay, so we've made our XY chart. We filled it in. Now we can go ahead and graph this. Negative 2, negative 8. Negative 1, negative 1, 0, 0, 1, 1, and 2, 8. Okay. Since it's a cubic, and this was before break, since it's a cubic, we do know that it should have an S shape of some form, right? Mm-hmm. Okay. So just do your best here. It doesn't have to be perfect. Again, on your assignment online, you're just going to be selecting the correct graph, right? Okay. You're not actually going to have to draw it out. Okay. Now this one is fairly easy to graph the second one. You don't need to spend your time with an XY chart because all I need to do to my red line or my red graph is what?
Move it to the right 3.
I just need to move it to the right 3 and down 1. So here I'm just going to go to each of these points, 1, 2, 3, and down 1. Hi. And then I'm going to regraph that. Okay. Now, if you would have chose to do your XY chart, should you have gotten the exact same graph? Yes. Okay, so we're describing the transformation first, and then we're graphing it. Questions on that one? We're going to do essentially the same thing on all 3 of these examples we're going to do today. They'll change it up a little bit on us, though. But really, it's all the same thing. Okay. Example 2. Is everybody okay on this one? Okay. Example 2 is the same idea, but they're doing more than just your translations left, right, up, and down. Okay, so the first one they give me here, we're not going to graph the first one, we'll just graph the second one. The first one they give me is f of x equals x to the 4th. And they want us to describe the transformation when we turn that into, bless you, g of x equals 3x to the 4th. Okay. So how do I know it's not a vertical or horizontal translation? Okay, I could still have a vertical translation without parentheses. I'm not adding or subtracting. Okay, your translations are adding or subtracting. This is going to be either a stretch or a shrink because I'm multiplying. Okay. Based on your chart, okay, and use that sheet I gave you, is this a vertical or a horizontal change? Vertical. Okay. And since the factor, or a, is 3, is it a stretch or a shrink? It is a stretch. So we would say this is a vertical stretch. Oops. By what? By a factor of 3. Okay. And we could graph that. I'm going to save us some time so you have more work time. We're not going to graph those. Okay. What would that have looked like if I wanted it to be a horizontal stretch? It could have been. It could have been a fraction here too, right? It just would have been a shrink. This would have changed it to horizontal. Okay, so very small changes. Remember, vertical, I changed the whole function. This is x to the 4th. This is 3x to the 4th. Horizontal, I'm changing only the input. I'm only changing the x before I take it to the 4th power. Okay, we'll do one of those here and then we'll graph it. So the second part of example 2, they give me x to the 5th. So there's my parent function. And then they want me to change it into 0.5x to the 5th power. They do something else on the end too, plus 2. Give me 1 second here. Okay. First, we need to describe our transformation. Cole, what's going on here? It is a horizontal stretch. Why is it not a shrink even though that number is less than 1? What's your chart say? It's a factor of 2 if a is 1/2, right? You guys see on where you have a horizontal stretch and shrink, they're backwards. Okay, if it's a fraction, it's a stretch. If it's a whole number bigger than 1, or any number bigger than 1, then it is a shrink. Okay, so it's kind of backwards there.
So,
Go ahead.
if it was 1/2, that's the same thing. Would it be a horizontal stretch?
If it was 1/2? Yes. So a stretch for horizontal stretches are any numbers between 0 and 1. Horizontal shrinks are any numbers bigger than 1. Okay. What else is happening here to this graph? Up 2. So I'm doing a vertical translation 2 units. Okay. All right, so if we want to graph this, I would start the same way we did on the first one. I just start with my XY charts, -2, -1, 0, 1, and 2. Okay, this is, fourth period got a little confused on this sometimes. If I'm taking something to the 5th power, is it going to end up negative or positive if I'm starting negative?
Negative.
It's going to end up negative. Remember, if this is an odd number, the signs are going to match, right? Okay. So -2 to the 5th power. Negative what?
32.
-32. Obviously, that's not going to fit on our graph, right? Is that a problem?
No.
Not really. Okay. -1 to the 5th power. -1. 0 to the 5th. 0. 1 to the 5th. 2 to the 5th. 32. So we graph these. First one we can't. -1, -1, 0, 0, 1, 1. What do you have to be careful of here, do you suppose? Those 3 points there make it appear like it should be a what? Appear like it should be a straight line. What do you know about a polynomial to the 5th degree, though? Yeah, anything bigger than a 2nd degree is pretty wavy, right? Okay, there's going to be multiple solutions. So I know for a fact that this can't just be a straight line, right? Okay, if you need to look up what it looks like, that's fine. On your big ideas, you're not going to have a lot of options. Okay, so you should be able to use some reasoning. Okay, but what's going to happen, I know that at -2, I'm clear down at -32, right? So it obviously got very steep right here. And on the other end at 2, I'm up at +32, so it must be very steep also. Okay, now this is one we haven't worked a lot with. If it's a 5th degree like this, it's actually going to be pretty flat here in the middle. Okay, you don't want to make it a very obvious S shape because that would be like a 3rd degree, like we did on the first graph. Okay. But you'll be able to see the differences there when you're doing your assignment because you're going to have just 4 options. Okay, so that's the first one. Now this, with our horizontal stretch in here, doesn't allow us to just grab these points and start moving them. Okay, so we are going to actually have to go back and make another XY chart and solve through this again. So I have -2, -1, 0, 1, and 2. Are you going to have to probably do all 5 of those points on your assignment? Probably not. Because when you start plugging some things in, you should start finding points on certain graphs that work and some that don't, right? Okay, so you might not have to do all of these points. -2 times 0.5. -1 to the 5th. -1 plus 2. 1. This one's a little bit harder. -1 times 0.5. Okay, I'm going to do it as a fraction. You okay with that? So I have -1/2. What is -1/2 to the 5th power? You got it, Damien. -1/32 plus 2.
2 -2
Plus 2.
No. So you're going to change that to
1 and
31.
31, 32.
Good job. 1 and 31 30 seconds. Is it okay, since you're doing an XY chart and you're not really giving me that answer. If you really wanted to, could you change it to a decimal?
Yeah.
Yeah. I just want to see if you guys could do that. 0 times 0.5. 0 to the 5th. Plus 2. 1 times 0.5. 0.5 to the 5th. Positive 1 over 32. Plus 2. 2 and 1 over 32. And 2 times 0.5. 1 to the 5th. Plus 2. 3. Okay. Will all those fit on my graph? Yep. -2, 1. -1, 1 and 31 32nds. 0, 2. 1 and 1, was it? 2 and 1 32nd, sorry. And 2, 3. Okay. What's that? What's that?
Yep, never mind.
You okay?
Got it.
Again, you're just making XY charts, plugging numbers in. Right? You won't have to plug all them in because you will be able to look at your graphs and compare them. Okay. The last thing I want to look at here with example 3, I'm not going to graph anymore. I'll let you get to your assignments and work on those a little bit. What they are doing is they're giving us two functions. They're giving me f of x equals x to the 4th minus x cubed minus 1. And then they are telling me they want g of x to be negative f of x. Yeah, so first of all, since it's just a negative sign, Austin, can you sit up for me, please? Thank you. Okay, since it's just a negative sign, what type of transformation is happening here? A reflection, and it's in the x-axis because on our sheets, okay, you can check your charts. Your charts say x-axis is when you change the outputs, which would be the whole function, right? Where would that negative sign be if it were a reflection in the y-axis? Inside the parentheses, it would look like this, right? Okay. Since this negative is on the outside of f of x, here's f of x, here's f of x, right? Okay, going back to a little geometry, I can substitute that in, right? Okay. So I have x to the 4th minus x cubed minus 1, which ends up turning into good. Okay. Reflections in the x-axis should be pretty easy because you just need to take that negative and put it on every coefficient in front of the variables. Okay. The directions on this one do say graph, but we're going to skip that. The last one I want to do, I want this same function, but I want to do g of x equal to 0.3 f of x. Before we do it, I want to know what type of transformation that is. Vertical shrink. Even though it's not a fraction?
I mean, it is a fraction.
It is a fraction. It's just not written as a fraction, right? Okay, it's between 0 and 1, so it must be a vertical shrink. Does this go to all the entire function or to just the x's?
The entire thing.
The entire thing, because this says 0.3 times the function of x, right? So same thing. 0.3, and I have x to the fourth minus x cubed minus 1. Distribute that, and I end up with what, Zach? Zach?
0.3 x to the fourth
Thank you.
minus 0.3 x to the third minus 0.3.
Thank you. Okay. And then if they really needed us to graph it, we could do that with an XY chart. Okay. That takes you halfway through this lesson of 4.7. You should be able to complete through problem number 21 on your assignment. So I need those done for tomorrow. Problem number 21. We will go on tomorrow and write the polynomial functions and do word problems.